Good morning students. Now we move on to the next topic in the compounds of the non-transition elements 1. In the previous class we have seen about the silicates, what are silicates and we also seen the classification of silicates. Now we see another compound, that is zeolites. Okay, the zeolites are also silicate containing compounds, but they are not pure silicates, but they are aluminosilicate compounds. That is, in addition to silicates or in addition to silica, they contain alumina. Alumina means AlO2. Okay, so it contains both alumina and silica. These type of compounds are called zeolites. This is a general formula for a zeolite. The general formula is MXN AlO2X times SiO2Y times and ZH2O, where M is the cation, any metal cation, not any metal cation, it may be a cation. Normally these metals are Na plus or calcium 2 plus, or it may be potassium plus. Then Al2 it's alumina and SiO2 silica. Then there is a water of hydration. And now see what is meant by this X, N and Z. Where X indicates the number of Al2 molecules. Okay, so X indicates the X from here. The number of molecules in the AlO2 is indicated by the X. N means the charge of the metal cation. That is, if you are taking sodium, the N will be equal to 1. If you are taking calcium, N will be 2. And if you are taking potassium, N is again 1. Okay, so how this formula will come, I will show with an example. Okay. Here you can see, these are some of the examples of the zeolites. Okay, first one is natrolite. Natrolite has a general formula Na2 AlO2 twice and SiO2 3 times and 2H2O. Here you see, in the general formula we have written this as M into Lm X by N. Okay, like that you have written there, where X is a number of SiO2 and N is a charge of the metal. So for this particular compound, this becomes M. If it is sodium, so the charge is 1. Sodium charge is 1, so 1 will come in the denominator and X will be AlO2 twice, so X is twice, so it becomes M2. Okay, this way the formula, general formula will be converted to the original compound formula. Okay, then you just consider this and this compound, that is zeolandite, that is a calcium containing aluminosilicate. Here also you can see M is equal M, the metal charge, this value indicates a number of metal atoms. Okay, so here 2 sodium atom is present. Here it is represented in the formula that one calcium is present. You can see whether it is 1. How this 1 come? Now we can see. So here the metal M, the formula is X by N. X means number of AlO2. So here it is number of Al2O2 is 2. Then you know that calcium has a charge of 2 plus. It is calcium 2 plus. So N also becomes 2. So this becomes M1. That is calcium. Okay, so this is the formula for the general compounds and also the formula for the particular examples of zeolites. Okay, these are the some of the examples of zeolites. Here you can see one more example, that is called permutate. You have seen this compound in your second, I think in the first sum or second sum. Okay, anyway you have studied in your earlier semester as a water purifier agent അല്ലെങ്കിൽ water softness ആയിട്ട് permutate യൂസ് ചെയ്യുന്നുള്ളത് നിങ്ങൾ ഒരു സെമസ്റ്ററിൽ പഠിച്ചിട്ടുണ്ട്. Okay, so this is about the zeolites. These are the some of the examples of zeolites. Now we can move on to the slides. So we have seen the general formula and also some of the examples of zeolites. Okay, then this Z indicates, this Z indicates the number of water molecules of hydration. Okay, so next another thing is that this I already told, it is alumina silicates, that they contain alumina and also silica, AlO2, and also it contains SiO2. Next structure is that it has a framework like structures. Okay, they have a framework structure enclosing cavities, and these cavities are occupied by ions and molecules like water, alcohol, ethyl alcohol, carbon dioxide and ammonia. You can just see the structure, then you will understand it more clearly. So this is the structure of a zeolite. Okay, here you can see these are either you see this example or you can see this example. They have a here you can see they have a framework like structure. നല്ലൊരു framed ആയിട്ടായിരിക്കും അവിടെ structure, and also the structures have cavities. Here also you can see these structures have some cavities. Okay, inside the cavities they have groups like, okay, inside ഈ അകത്തോട്ടെല്ലാം തന്നെ they have groups like water molecule, ammonia or CH2OH or carbon dioxide. Okay, then another thing is that you know that they contain some metal atoms, like sodium or calcium or potassium will be presenting along with this zeolites. So one thing is that these metal ions can pass through this cavity. Okay, ഈ cavity കൂടെ ഈ metal ionsന് അകത്തോട്ടും പുറത്തോട്ടുമുള്ള passage possible ആണ്. Okay, that is another thing. And the structure, when you look at the structure of zeolites, you can see that they have a framework like structure having cavities enclosed within, and inside the cavity they have some groups like water, ammonia, alcohol, carbon dioxide, etc. And another important property of the zeolite is that through this cavity the metal ions can move inside and outside the molecule. Okay, they can either move outside the molecule or some of the molecule from the outside can enter inside the cavity. So there will be an exchange of metal ions is also possible in the zeolite structure. Okay, now we move on to the presentation. So this is a second point I have told. The cations can move freely through the open pore structure. So what happened is that because of this property, that is, the cations can move freely through the open pore structure, because of this property, the zeolites can be used as water softeners. Because you see here they have Na plus ion. When we pass the zeolites through a hard water, what is the peculiarity of hard water? Hard water contain calcium 2 plus and magnesium 2 plus ions. Okay, if we pass hard water through these zeolites, what happened is that suppose this is a zeolite cavity having Na plus ion, we are putting this in hard water. Hard water means it contains what? Calcium 2 plus. Okay, so what happens is that this Na plus will move from the cavity, move outside the cavity, and to that place calcium 2 plus enters. Okay, so now the calcium 2 plus will be placed inside the zeolite and Na plus will go outside. That is, the hardness can be removed by this method. Okay, you understand? These cations can be easily exchanged with other cations. അല്ലെങ്കിൽ നമുക്ക് പറയാം ഈ കാറ്റോൺസ് ഇതാണ് ഈ ഫസ്റ്റ് വരച്ചിരിക്കുന്ന സർക്കിളാണ് സിയോലൈറ്റ് എന്നെടുത്താൽ സിയോലൈറ്റിനകത്തുള്ള Na പ്ലസ് സിയോലൈറ്റിൻ്റെ ക്യാവിറ്റീസിൽ നിന്ന് പുറത്തോട്ട് പോകുന്നു. അങ്ങനെ പുറത്തോട്ട് പോകുമ്പോൾ പുറത്തുള്ള ഹാർഡ് വാട്ടറിലുള്ള കാൽഷ്യം 2 പ്ലസ് അങ്ങോട്ട് വരുന്നു, അകത്തോട്ട് വരുന്നു. Thus the calcium present in the hard water can be removed. So the zeolites are used as water softeners. Okay, because they can be reversibly exchanged with other cations. That is, sodium plus can be exchanged with calcium 2 plus, or potassium plus can be exchanged with calcium 2 plus in the hard water. So are used as water softeners. Okay, so another important property of this zeolite is that they are used as molecular sieves. What is meant by sieves? Sieves means just like our repellent. We are filtering something, used for filtering something. Okay, so we have already seen the structure. They have some cavity, and also you have to remember that cavity should have a particular size. Avade size ennu parnal specific aayirikkum. So what happened is that they absorb small molecules that enter the cavity. Whatever small molecules that is entering the cavity, they will absorb it. Okay, suppose that you have a mixture of a hydrocarbon, a polymeric hydrocarbon. Okay, polymeric hydrocarbon means CH like that. Okay, here I can write it is CH. Okay, this is a straight chain hydrocarbon. Suppose if it is a branched hydrocarbon, what happens? Here there is another CH, then CH, then here CH, it will be good. This is a branched hydrocarbon. Okay, so this is a branched hydrocarbon and this is a straight chain hydrocarbon. Which one is smaller in size? most probably this straight chain will be small in size, because here due to the branching the size will be here everywhere branching can be possible, so size will be much larger. So if we pass a mixture of straight chain hydrocarbon and a branched chain hydrocarbon to zeolite, what happens is that because of the small size, the straight chain hydrocarbon will enter inside the cavity of zeolites. So what is left outside is the branched hydrocarbon. Thus we can separate straight chain from the branched chain. So we are just like sieving it. Based on the size we are sieving the straight chain and also the branched chain. Okay. So these are the important applications of zeolites. So zeolites are aluminosilicate compounds, and they are used as water softening agents, and also they are used as molecular sieves. Okay, example I have already shown in that image. These are some of the examples of zeolites, and the most important example is permutate, that is used in a permutate process for water softening. Next, associated with this compound there is another compound that is called ultramarines. Okay, and ultramarines, what are ultramarines? So this is ultramarines. Ultramarines are also aluminosilicates. They are also aluminosilicates, but one difference is that they do not contain water. We have seen in the zeolite that zeolite inside the cavity they have ions like water, ions or molecules like water, carbon dioxide, ammonia, etc. Okay. In this ultramarines or in the zeolite, if water is absent, then it becomes ultramarines. Okay, so in ultramarines the cavity does not contain water molecules. Instead of that, they contain other ions like Cl minus, S2 minus or SO4 2 minus ions may be present. Okay, so another thing is that many of these are colored and they are used as pigments. Some of the common examples are ultramarine, then sodalite, etc. The some of the examples of ultramarines. Okay, so ultramarines are also aluminosilicates without water molecule. Now move back to the presentation. Okay, so zeolites are over, then ultramarines are over. Next we move on to the next compound, that is silicones. Okay, don't confuse with silicates and silicones. Silicates means SiO4. Silicones means what we will see now. Okay, so silicones are organosilicon polymers. Polymers you all know, high molecular weight compounds are called, or substances are called polymers. Normally you have heard about organic polymers, that is they mostly contain carbon, hydrogen, like that. Okay. Here what happened is that this organosilicon, that is here organic part is also there and also silicon is also associated there. So we have an alkyl or aryl group along with silicon atom giving a polymer. They are called organosilicon polymers. Why it is important is that these silicon compounds are used commercially. They are used as oils, resins, rubbers and fluids. Okay, they have very important commercial applications. That is importance of this silicon compounds. Okay, now we can see more detailed about what are silicones and how they are formed, etc. The formation of silicone starts with this particular reaction. Okay, this reaction explains that if we take a chlorosilane, that is a silicon connected with 4 chlorine atom, if we take a chlorosilane and if we hydrolyze it, what happened is that 4 SiO4 is replaced by OH. Okay, what happens here is that there one SA is there, then each earlier it was 4 Cl was there. When you hydrolyzed, all the 4 Cl is converted to OH molecules. Okay, next a molecule with 4 OH, it is very unstable, so immediately it will undergo dehydration, that is water molecules will be eliminated. Okay, so what happens here is that water will be eliminated like this. From here and H2 will go, and also from here and the H2 will go. So what you are getting is SiO2. Okay, this is one of the common reaction of this chlorosilane compounds. Okay, chlorosilanes on hydrolysis give a hydroxyl compound, and this hydroxyl compound immediately undergo dehydration to form a SiO2, a silica group. Okay, so this reaction is conducted to alkyl substituted chlorosilanes. That is, this is the compound. What happens, what is the peculiarity of this compound? Here it is also similar to SiO4, but only difference is that 2Cl is replaced by 2R groups. Okay, here what happened is that 2Cl2 group is replaced by 2R group. So what we are expecting, similar to this reaction, we are expecting that if we hydrolyze this compound, what happened is that the 2Cl will be replaced by OH groups. Okay, next what we will expect, as 2 OH group in one atom is very unstable, so immediately it will eliminate a molecule of water to form RR and SiO2. Okay, this compound is expecting, but normally we will not get this product. That is, I put an into mark here. Okay, so when alkyl substituted chlorosilanes are hydrolyzed, the end product is not the expected one, but we get some other product. What is the product we obtained is that, up to this, that is, we have taken a dialkyl substituted chlorosilane, it undergo hydrolysis. The next step it happens is that, so this is a compound, first ഈ എഴുതിയിരിക്കുന്ന compound തന്നെയാണ് ഇത്, that is silicon 2R group and 2 side 2 OH. Then what happened is that it will react with another molecule of same compound. Okay, same compound in another molecule might react. Okay, so it react with another molecule of the same compound, and from here by the condensation, that is 2 molecules get condensed here. Okay, here the first molecule and the second molecule condense together, removing a molecule of water, and you get the compound OH SR2O SI. That is, a bond is formed. Which type of bond? SiOSI. That is, രണ്ട് മോളിക്യൂൾ കമ്പൈൻ ചെയ്തിട്ട് നമുക്ക് എന്ത് കിട്ടുന്ന ഒരു പുതിയ ലോങ് ചെയിൻ ആയിട്ടുള്ളൊരു മോളിക്യൂൾ കിട്ടി. ഓക്കെ, ആൻഡ് ദിസ് പ്രോസസ് കണ്ടിന്യൂസ്. നെക്സ്റ്റ് സ്റ്റെപ്പിൽ എന്താ സംഭവിച്ചത്? ദിസ് പ്രോഡക്റ്റ് കമ്പൈൻസ് വിത്ത് അനദർ മോളിക്യൂൾ ഓഫ് ദ ഇനീഷ്യൽ പ്രോഡക്റ്റ്, അല്ലേ? അല്ല, അനദർ മോളിക്യൂൾ ഓഫ് ദ ഡയാൽക്കിൽ ഡൈഹൈഡ്രോക്സി കോമ്പൗണ്ട്. ദാറ്റ് ഈസ്, ഈ കോമ്പൗണ്ട് വീണ്ടും ആരുമായിട്ട് റിയാക്ട് ചെയ്തു? ഈ ഫസ്റ്റുള്ള സ്റ്റാർട്ടിംഗ് മെറ്റലായിട്ട് റിയാക്ട് ചെയ്തു. എഗെയിൻ ഇവിടുത്തെ OHും ഇവിടുത്തെ Hഉം കൂടെ പോയി ടോട്ടലി എത്ര മോളിക്യൂൾ കണക്ട് ചെയ്തു? 3 മോളിക്യൂൾസ്, അല്ലേ? 1 2 3 മോളിക്യൂൾസ് കണക്ട് ചെയ്തു. ഇതിങ്ങനെ ഒരു ചെയിനായിട്ട് കണ്ടിന്യൂ ചെയ്തു. ഈ പ്രോസസ്സിനെയാണ് നമ്മൾ എന്തെന്ന് വിളിക്കുന്നത്? പോളിമറൈസേഷൻ എന്നും, അങ്ങനെ കിട്ടുന്ന പ്രോഡക്റ്റിനെയാണ് നമ്മൾ പറയുന്നത് പോളിമേഴ്സ് എന്നും പറയുന്നത്. സിൻസ് ഇറ്റ് കണ്ടെയ്ൻസ് R group, R groups means organic groups are there, and also it contains SiO bond, so they are called organosilicon polymers. Okay, now you understand why it is called organosilicon polymers, because it contains both the organic part and also SiO like that silicon containing bond, so it is organosilicon polymers. Okay, so this long chain polymers formed by the hydrolysis of alkyl substituted chlorosilanes are called silicones. So what are silicones? They are the long chain polymers formed by the hydrolysis of alkyl substituted chlorosilanes. So next we move on to the next slide. So next, if we take a monosubstituted chlorosilane, in the previous example we have seen a silicon with 2R group, silicon with 2R group, remaining എല്ലാം എന്താണ്? OH and OH. And if you are taking a monosubstituted alkyl silane means what? Only 1R group is there. Only 1R group is there, remaining 3 valencies are occupied by OH groups. Okay, if they undergo reaction, what happened is that first these 2 OH will react. Then here in the first stage itself we are taking 3 molecules. Okay, 1 molecule, then 2 molecule and 3 molecule we are taking together. So first these 2 will react, then this side these 2 will react, so 3 molecules combines together to form OH SiO 3 മോളിക്യൂൾസ് കമ്പൈൻ ചെയ്തു. നെക്സ്റ്റ് സ്റ്റെപ്പിൽ നിങ്ങൾ ഇവിടെ കാണുന്നു താഴെയും ഒരു OH ഉണ്ട്, അല്ലേ? താഴത്തെ സ്റ്റെപ്പിലും എല്ലാം OH ഉണ്ട്. സോ നെക്സ്റ്റ് സ്റ്റെപ്പ് വാട്ട് വി ഡിഡ് ഈസ് ദാറ്റ്, ഈ കിട്ടിയ മോളിക്യൂളിനെ ഇവിടെ വെച്ചു, അതിൻ്റെ താഴെ അടുത്ത മോളിക്യൂൾ വെച്ചു. ഓക്കെ, മേ ബി ഈ ഒരു ഫസ്റ്റ് മോളിക്യൂളിനെ നിങ്ങൾക്ക് എന്ത് ചെയ്യാം? ജസ്റ്റ് ഒന്ന് റൊട്ടേറ്റ് ചെയ്തിട്ട് വെക്കാം. സോ ദിസ് സൈഡ് ഓൾസോ ക്രോസ് ലിങ്കിങ് ക്യാൻ ബി പോസിബിൾ. സോ ദിസ് വിൽ റിസൾട്ട് ഇൻ എ കോംപ്ലെക്സ് ക്രോസ് ലിങ്ക്ഡ് പോളിമേഴ്സ്. ഓക്കെ, ഇഫ് ദർ ഈസ് എ മോണോ ആൽക്കൈൽ, നിങ്ങൾ ഇത് നോട്ട്ബുക്കിൽ എഴുതി നോക്കണം, ജസ്റ്റ് ഈ പടം മാത്രം കണ്ട് പോയാൽ പോരെ. യു ഷുഡ് റൈറ്റ് ഇൻ യുവർ നോട്ട്ബുക്ക് ആൻഡ് അണ്ടർസ്റ്റാൻഡ് ഹൗ ദിസ് റിയാക്ഷൻ ഈസ് ഹാപ്പനിങ്. Okay, so if you take a monoalkyl silane, you will get a complex cross-linked polymer. So we can see that organosilicon. So from these two examples we can see that organosilicon polymers with different properties can be obtained by using different starting materials. Okay, if we change the number of alkyl groups, okay, if we make it as 1, if we make the number of alkyl group as 1, we get a cross-linked polymer. If we take the number of alkyl groups at 2, you will get a linear chain polymer. So based upon the nature of the starting material, you will get different products with different properties. Okay, so what the product, if you are using a dimethyl dihydroxysilane, that is the first example we have used, like Si R and RR, and here it is OH and the race OH. That is, if you are using a dialkyl and a dihydroxysilane, the product obtained are called silicone oils. Okay, they are called silicone oils. Okay, if you are using a dihydroxy dimethyl silane, the product obtained are called silicone oils. The important property of the silicone oils is that they are stable at high temperature than mineral oils. Okay, normally the mineral oils the silicone oils are highly stable at high temperature. Then another property is that they have less tendency to thicken at low temperature. You know, when we keep oil at very cold temperature, what happened is that they will get thickened. Okay, but for the silicone oil it will not get thickened. So these are the two characteristics of the silicone oils. Okay, next is another commercially important product of this silicone polymer is silicone rubber. How the silicone rubbers are formed? These are if the chains are bridged by ethylene or similar groups, then it results in a silicone rubber. Okay, if silicone polymers are formed and the two different chains are linked by ethylene groups, that is CH groups, then the resulting compound are called silicone rubber. This way it is happening. Here you can see this up to this part similar to whatever you have seen, that is one silicon atom. Instead of 2 R group, we have put here 2 CH3 groups, and SiO linkage has formed, and the silicon CH3. Okay, this we have already seen. Next, what happened is that here you can see here there is a CH3, and here also there is a CH3. If we use a radical initiator, maybe you have seen somewhere there is a mechanism for a chemical reaction called a radical reaction, free radical reaction. In free radical reaction, what happens is that if you have a CH3 group here and we have a CH3 groups here, a free radical will come. A free radical initiator is like a catalyst. It will come. It will remove one hydrogen from here, that it becomes CH2. Okay, this CH3 becomes CH2 radical plus a hydrogen radical. Okay, similarly another CH3 will also become CH2 radical plus H radical. This happens only in the presence of a free radical initiator. So here also this happens, that is this CH3 is converted to a CH2 radical plus a hydrogen radical, and here also this CH3 converted to a CH2 radical plus a H radical. Next up, what happens is that these two radical will combine together to form a bond. That happens here. We are seeing here one CH2 and one CH2 bonded by. So what happens here is that two silicon chains are connected by a ethylene group. Okay, two silicon chains are connected together by a ethylene group. Then this compound is called a silicone rubber. Okay, so these are the different types of silicone polymers. We have seen about silicone oils. We have seen about silicone rubber. Next, we have to see the different applications of the silicone containing polymers that just we can read. So these are the properties and uses of the silicone oils. Depending on the length of the chain and nature of the groups attached to silicon atom, silicones may be obtained in the form of oil, fluids, resins or as rubbers. Okay, a chain in the length മാറുന്നതിനനുസരിച്ച് അത് only oil ആകാം അല്ലെങ്കിൽ fluid ആവാം or resins or rubbers ആകാം. The silicones have many desirable properties. They are resistant to heat, oxidation and most chemicals. They are strong water repellents. Why they are water repellent is that you may be remembering the structure. Outside they have lot of R group, alkyl groups ഇഷ്ടം പോലെ ഉണ്ട്. അതുകൊണ്ട് alkyl groups means they are hydrophobic, so they are water repellents. Okay, and also they are good electrical insulators. They have a non-stick properties and anti-foaming properties. The two important properties ആണ് ഒരു non-stick propertiesഉം അതുപോലെ തന്നെ anti-foamings. അങ്ങനെ പതയത്തൊന്നും ഇല്ല. Okay, the strength and inertness are due to the stable silica-like skeleton. The strength is due to the presence of the silica-like skeleton. Then SiO bond energy is very high, and the another thing is that the high strength of C bond. Okay, they are the strength and inertness reasons എന്ന് പറഞ്ഞാൽ എന്താണ്? Due to the strength of the bond SiO and also SiC bond. Then the water repellency of silicones arises because a silicon chain is surrounded by organic side groups and thus looks like an alkane from outside. Okay, and that is another point. Then straight chain polymers of 20 to 500 units are used as silicone fluids. These fluids are used as water repellents for treating masonry and buildings, glassware and fabrics. Okay, the building constructions like a water repellents ആയിട്ട് എന്താണ് 20 to 500 units വരെയുള്ള silicone fluids യൂസ് ചെയ്യാറുണ്ട്. Then also used in shoe polish and also car polish. What are the properties we record for a shoe polish? It should be like oily appearance it should have, but it should be non-sticky. But non-sticky ആയിരിക്കണം, but you have to get an oily appearance. Then another thing is that it should be water repellent. So these two properties we are getting from the silicone oil, so we are using it in shoe polish and also car polish. Then the presence of few parts per million of silicone reduces foaming in sewage disposal, beer making, textile dyeing, etc. അപ്പോൾ silicone oils ഉണ്ടെങ്കിൽ ആ സൊല്യൂഷൻസിൽ നടക്കുന്ന ഫോമിങ് നമുക്കൊന്ന് റെഡ്യൂസ് ചെയ്യാൻ പറ്റും. സോ ദേ ആർ മെയിൻലി യൂസ്ഡ് ഇൻ സീവേജ് ഡിസ്പോസൽ, ബിയർ മേക്കിംഗ്, ടെക്സ്റ്റൈൽ ഡൈയിങ്, എക്സെട്ര. Then silicone oils are used as dielectric insulating material in high voltage transformers. Already it has shown that they are not electrical insulators. Then methyl silicones may be used as a light duty lubricating oil. They can be used as lubricating oils. Then silicone rubbers retain their elasticity from minus 90 degrees Celsius to plus 250 degrees Celsius, which is a much wider range than that of natural rubber. അപ്പം റബ്ബറിൻ്റെ പ്രത്യേകത എന്താണ്? They should be elastic. That is, if you stretch it, it should be elastic, which should not break. അല്ലേ, ഒരു പർട്ടിക്കുലർ അല്ലെങ്കിൽ ഒരു പർട്ടിക്കുലർ സ്റ്റേജ് വരെ അത് എന്ത് ചെയ്യണം? സ്ട്രെച്ച് ചെയ്ത് തന്നെ നിൽക്കണം. But what happened is that as the temperature increases, നിങ്ങൾ നോക്കിയാൽ മതി, ഒന്ന് ചൂടാക്കി എന്താണ് elasticity minus temperature, it is വളരെ cold temperature-ലോട്ട് if you are keeping the rubber band in a very cold temperature, it becomes brittle. So when it stretches, it will break. Okay, so what are the advantage of the silicone rubber is that its elasticity can be retained up to a temperature of minus 90 degrees Celsius and also to a high temperature of 250 degrees Celsius. Okay, so it is advantageous than natural rubber. Then they are also good electrical insulators. Already told, on vulcanization they give hard rubber. Like natural rubber, we are adding sulfur linkages. Here also you can add vulcanization means adding sulfur, then you can increase its rigidity can be increased, so it becomes rigid like bakelite. Okay, bakelite is a phenol formaldehyde resins ആണ് നമ്മൾ bakelite എന്ന് പറയുന്നത്. It's a hard substance ആണ്. Okay, then they are used in electrical insulators, in non-stick coatings for pans and molds or car tires. They are used to make printed circuit boards. അപ്പോൾ electrically insulator ആയതുകൊണ്ട് circuit boards ഒക്കെ ഉണ്ടാക്കാനായിട്ട് യൂസ് ചെയ്യുന്നത്. So these are the applications of this silicones. Okay, so another thing I have to say, remember you, is that don't confuse with silicate and silicones. If you are asked about silicate and its classification, you should go for SiO4 and orthopyrosilicate, like that. If you are asked for silicones, okay, so please read the question carefully during examination. If it is asked for silicone and its classification, means here also you have different classification, like simple chains undavam, cross linked chains undavam. So here also different types of classifications you will get. So silicones means organosilicon polymers and also their application. Okay, so that is all for now. Thank you all.